So I have four different dt graph. Number 1, 2, 3, 4, 4 complicated dt graph, and I'll teach you how to convert them to vt graph, and then I'll also show you how to calculate area under vt graph, which we call displacement or distance. Yep. I have a graph like this and I have a graph like this, so I want to make a distinction between this. So this one must be what free fall scenario this one does represent. I have to figure that out. So these all are free fall. These all four scenario represent free fall. But what types of free fall is this one? Initial velocity must be 0, because this slope is steeper than this slope. This slope is much more steeper than this slope. So this must be thrown down. And this must be drop. This must be dropped, and this must be thrown down with some initial velocity, okay, because this one is steeper. So first I'm going to do this one. All right, 3 seconds. So I know 3 seconds. I know initial velocity is 0. So initial velocity is 0 because this is dropped. So I'm going to draw vt graph. If the dt is curved, then vt must be a diagonal. All right, so let's draw a diagonal line. All right, so this is a vt. If dt is curved, vt must be a diagonal line. Okay, we accomplished that. Now I also have to find the velocity right here. The velocity right here. We're going to use z is equal to -10 meter per second square today. So the velocity must be -30 then. How do I figure that out? V is equal to vi plus at, and that tells us that velocity must be -30. If you don't know what am I talking about, you can plug that in. This is 0 because this is dropped, and this is -10 times time is 3. So this is how I know the velocity, which is -30 here. So with that I can find the displacement. So let's find the displacement quickly. So this is the displacement, and the displacement formula is area under the curve, which is half bh. So displacement is half, b is 3 seconds, and height is -30. So the displacement is -45 meters. So the displacement is -45 meters. Not the best color. Displacement is -45. -45. Okay, so displacement is -45 meters. Now we're going to do exactly the same thing, but thrown downward. This ball was thrown downward because this is steeper, this one is steeper than this. So let's see how we can do that. So then there must be thrown downward means initial velocity is less than 0. So let's say initial velocity is 3 meters per second. Since you throw it down, it has to be negative. So let's say initial velocity, this ball was thrown down with initial velocity 3 meters per second. So negative 3 meter per second means someone throw it down by 3 meter per second is negative 3. So we have to find the final velocity. Now probably you want to think about how we're going to find the final velocity. Final velocity is very easy, negative 33, since initial velocity is negative 3. If you don't know how, then you can always check your guess. So this is negative 3 minus 10 times 3 seconds. The total trip is 3 seconds, so 3. So that gives you negative 33. All right, so this is negative 33. So this is negative 3, and let's say this is negative 33. That's the final velocity. So we'll start it from initial velocity. Initial velocity. Okay. All right. So this is the area under the curve. This is area under the curve. We can divide it in two parts. One part is a rectangle, and one part is the triangle. Okay, good. We are almost done. So then, now you probably think, how can we calculate the displacement? Very easy. So let's first find the displacement of this one. So displacement of this one is equal to BH, since this is a rectangle. So displacement is B is 3 seconds. Height is this one height is negative 3, because negative 3 is your initial velocity. So this is negative 9. So I'm going to write negative 9 here. Okay. Now I'm going to find this one. This one is half BH. So half, base is 3, and height is 33 minus 3. Okay. Negative 33 minus 3. Minus 3. So which is minus 30. So half, you don't have to write half. So this 2 goes to 30 15 times. So this gives you 45, negative 45. So this is negative 45. If you add them up, what do you get? You get 54. You get 54. So 54 meter. In this case, what did you get? You get 45 meter. 45 meter. Displacement is negative 45 meter. Let's write it nicely. Negative 45 meter, and displacement is negative 54 meter. Okay.